The next example I want to look at involves dividing rational expressions. We'll start with dividing fractions using the same method we'll use with rational expressions and then extend it to rational expressions. So let's take 3/4 divided by 15/16. When it's written like this, you've been taught, and this is a good way to think about it, is when you have one fraction divided by another fraction, we can multiply by the second fraction, or the one that we're dividing into this one. So I could rewrite this as 3/4 times, change it to a multiplication, the reciprocal of this number. And so that will be, the reciprocal of 15/16 is 16 over 15. So change it to a multiplication. Now let's do what we did before with the factors, and let's find all the prime factors here and then see if we can divide some out. 3 is prime. We can leave it like that. 16 is, well, let's I guess do the new denominator here first. 4 is 2 times 2. 16 is 2 times 2 times 2 times 2. Those are all of its factors, prime factors. 15 is 3 times 5. Once we have it in factored form, we can divide out common factors to the top and bottom. There are, let's see, they have a 3 in common, a 2 in common that I already got, and then they have another 2 in common. What we're left with is a 2 times 2 on top and just a 5 on the bottom, or we could write that as 4/5. So that's what we get using this method to divide fractions. Change it to multiplication, and then do what we did before. We multiplied, find the prime factorizations of the numerators and denominators, and then remove any common factors from the top and bottom. Okay, let's look at an example with rational expressions. Same thing. If we can factor these, we can simplify them very easily. First of all, let's change it to a multiplication problem. This fraction or rational expression will stay the same, but now we're going to multiply by the reciprocal of the second one. And the reciprocal will be 3x squared plus 3 over x squared plus x minus 2. Now we have an expression like we had previously. We're multiplying two rational expressions. So we want to find the factors and then see if there are any common factors that we can cross off. So x squared minus 2x plus 1. Let's try to factor that as two binomials. It looks like x minus 1 and x minus 1 will work. X cubed plus x. It's a binomial, but we should try to factor out the greatest common factor first. Looks like they have an x in common. Let's take that out. What we're left with is x squared plus 1. And x squared plus 1 we can't break down even any farther. It doesn't fit one of our patterns for a binomial. Let's move over here. And here again we have a binomial, but we should try to take out common factors first. Looks like they have 3 as a common factor. So I'm going to take a 3 out. What I'm left with is x squared plus 1. And down here, let's try to take this trinomial and factor it as two binomials, x. It looks like plus 2 minus 1 will work because 2 times negative 1 is negative 2. 2 plus negative 1 is positive 1. So that should work for that polynomial. Okay, now let's look for common factors that we can divide out. I like to start on the top left. There's an x minus 1 up here, and there's 1 down there. So let's cross those out. Another x minus 1. I don't see any other ones on the bottom. That one stays. A 3 on top. I don't see any 3's on the bottom. That will stay. X squared plus 1 is another factor. There's one of those on top and one on the bottom. So let's divide that out. And that's as much as we can do because we looked at all the factors on top. What we're left with, we have a 3 and an x minus 1. We like to put the numbers first, so I'll put 3 and an x minus 1. That's the numerator, and then the denominator we have an x and an x plus 2. And again, you could multiply this back out and get a couple of polynomials in standard form, but for me it's fine to leave it in factored form.